So classified questions from atomic physics, we did the first 3 pages. You can annotate on the screen. The first one isotope of iridium 194 is represented by the symbol, as you can see, and by the emission of a beta, it turned into platinum. Complete the nuclide notation. So whenever there's a beta emission, the nucleon number does not change. But what happened to the proton number? The proton number will increase by 1. Why the proton number increases by 1? Because one of the neutron breaks into proton and electron. Neutron number decreases by 1, proton number increases by 1, but the nucleon number does not change. So this will be 78 and this symbol for beta. The half-life is 19 hours. A sample has an initial count rate of 1100 every minute. Calculate the count rate from this sample after 38 hours. So how many half-lives should pass? So 2 half-lives will pass. So it means in the beginning, we'll have 1100. After 19 hours, what will be the count rate? Half of 1100, which is 550. And then after another 19 hours, 275. So this will be 275. This question, because sometimes they give a question in which you have to include a background radiation. If in this one, no concept of a background radiation was there. State 2 ways in which the gamma emission differ from beta emission. How they're different from each other. How gamma emission is different from beta. Gamma is a radiation where beta is a particle. That is one thing. Gamma does not have charge. Beta is charged. And what else? You can compare their ionizations as well. Can cause a greater ionization than alpha. Or gamma is not deflected by magnetic field. Gamma is not deflected by electric or magnetic. Beta can be. As this is an open response question, as multiple answers are possible. As you can see here, the comparison between them in the marking scheme, like radiation, charge, mass, range, how it can be stopped, ionization power, and deflection in electric and magnetic field. You can annotate on the screen and complete this table. We have the isotope of helium. One is helium 3n2, another one is helium 4n2. Number of neutron in this helium. How many neutrons will be there? So this will be 1 and 2. Number of electrons. 2, because it's a neutral, so number of electron and proton should. When we compare with a hydrogen, like if we compare the mass with hydrogen, this helium is how many times heavier? 3. And this helium is how many times heavier? 4. So 3 is to 4. Helium nuclei is also known as an alpha particle. An experiment takes place in a lab, shielding from all background radiation. A sample of a radioactive material is wrapped in aluminum foil of a thickness of 0.1 millimeter. A detector of ionizing radiator like GM tube is placed 1 centimeter from the foil. There is no background radiation, as I mentioned in the beginning, that the lab is shielded from no background radiation. A piece of aluminum of thickness 5 millimeter placed between the detector and the foil, the detector readings drop to 0. State and explain any type of radiation passing through the aluminum foil. So first, if you see a radioactive source is there, a sample of a radioactive material wrapped in aluminum foil. Like, say this is a sample of radioactive source and we wrapped in aluminum foil. And then we place a piece of aluminum of thickness 5 millimeter. So there's a 5 millimeter aluminum is placed and the detector records 0. State and explain any type of radiation passing through the aluminum foil. Aluminum foil, they are saying. So aluminum foil, yes, You can, but instead of 3 marks, you cannot say, I will just a minute, Mira. Uh, See the sample answer. So first thing, there is beta. Why there is beta? Because when we place an aluminum sheet or a piece of aluminum, then the count reduces to zero, as I mentioned here. So a piece of aluminum of thickness 5 millimeter and the detector reading dropped to zero. So when there was a sample and we place an aluminum, the detector was recording some value. But the moment we place the aluminum, then the reading record turned to zero. The question is state and explain any type of radiation passing through aluminum foil. Any radiation was passing and it was only 0.1 millimeter thick. So 0.1 millimeter is not like it can reduce the beta, but it cannot reduce to zero. Some beta can still penetrate through 0.1 millimeter. So there was radiation passing through aluminum foil, that was beta radiation. But when we place a piece of aluminum which is 5 millimeter thick, that will completely block the beta radiation. So aluminum foil, the beta was passing, but aluminum piece, the beta was not passing. That's why if you see the marking scheme points, the answer beta would, it will be stopped by the aluminum, but so it was beta because beta radiation was passing and 5 millimeter thick will stop. There was no alpha. Why there was no alpha? Because alpha can easily be stopped by aluminum. And there was no gamma because the gamma can easily pass through 5 millimeter aluminum. State the proton and the nucleon number for alpha particle. How many protons? 2 proton. Nucleon is 4 and the charge is +2. Good. A nucleus of a strontium which has 38 protons and 52 neutrons, it emit beta and it turn into yttrium. The symbol of strontium is given to you. Write down the nuclide equation. So first we have strontium, which is 90 and 38. It emit out beta, which is 0 and -1. So what happened to nucleon number does not change, and what happened to proton number? It increases by 1. The half-life of a radon is 56 seconds. A sample of a radon is a container after 112 seconds as a mass is 9.2 milligram. After 112 seconds, the mass of a radon, calculate the original mass of the sample. Like we have now 9.2. So for this, you have to do reverse. Like right now, we have 9.2 milligrams. Okay. Before 52 seconds. Oh, sorry, 56. Before 56 seconds, how much mass should be there? Before, not after. 9.2 multiplied. Like it should be double. Like because after it will become, but remember one thing, the total mass does not change. The proportion of the sample only changes. So it will be 9.2, it will be 18.4 milligrams. Then before another 56 seconds, I'll use the space here. So, so we have 9.2 milligram. Before 56 seconds, it was 18.4. Before another 52 seconds, 56 seconds, sorry, it will be 18.4 multiplied by 2. So 36.8. So 36.8 milligram will be there before 112 seconds. Because like this was the original, after 112 seconds, we have 9. In these questions, you are not supposed to show the like any right formula, but you have to show this how you worked out. Yes. Yes. Two half life. Yes, you can do that as well. Like 2 raised to power of the half, that will also give that. Use screen annotation to complete the decay for alpha. So nucleon number, it decreases by 4 and the proton number decreases by 2. So this will be 93. Then describe how americium ionizes air. This is because air, how ionization can happen or occur. The sample answers the reason. So what answer? Alpha particles which are emitted from americium, they collide or they hit the air molecules and they knock out the electron. 1 mark alpha particle is emitted from the source. 1 mark it collide with a air molecule, and 1 mark it knock out the electron. And then next is why beta is why alpha. Suggest two reasons why it use alpha rather than gamma. Because one is for short range. Alpha is having a short range. Otherwise, if it was a gamma, then it will be dangerous because gamma is having a long range. So if a person is exposed for a gamma radiation, long-term exposure can cause cancer. So that's why the one reason is related to danger of radiation. Alpha is having a short range, so it can remain in the same space. And the second thing is ionization. Alpha is better ionizer than beta, than gamma. So as you can see here, the alpha not petri having a short range, alpha more high ionizing as compared to that of gamma. So it is less harmful for the use.